In this video, we're going to show you how to complete part C of your weather patterns lab. First thing you're going to need is this particular map here that's sitting on front of you on the camera. You guys should have this already drawn from a previous lesson. If for any reason you were absent, we'll show you in a little bit how we actually set this up and have you go ahead and do that part first before going on to this next part. You're also going to need a series of colored pencils. We're going to need a blue, a red, and a purple. Those are going to be to go ahead and to draw our fronts. And then a little bit later, we're going to need to use yellow and green to go ahead and shade in some precipitation and other moisture factors. So make sure that you have those colored pencils before you continue on with this video. You're also going to want to make sure you have your weather patterns lab open from our Schoology page, and we are on part C where you'll find the procedure for what we're doing here. Now, in the previous lesson, we labeled our two high pressure systems with a big H, and we know those were the high pressures because we looked at the values on the isobars, and these had the highest pressures in those locations. So we have one on the corner of Montana, Idaho, and Wyoming, and we have another sitting here in the southeast United States over places like North and South Carolina and part of Georgia there. Then we had two low pressure systems. We have a big low pressure system sitting here over Mexico, and we have our main low pressure system sitting over South Dakota, and that's the big storm that we're going to be analyzing today. There is a third low pressure, Karen, down in the Gulf of Mexico. You might remember we said that symbol is a tropical storm symbol, and we'll talk about Karen in some of the questions that are coming up in a little bit. The other thing we did was, just to remind you, we color-coded our wind directions. Anything in red is a southerly wind, and that's transporting warm air from the equator northward. Anything in blue is a cold wind from the north, any northerly direction, and that is transporting cooler air from the north down toward the lower latitudes. Our task in this lab is to go ahead and draw in the fronts, and lines have been provided to show you where the fronts are, but the symbols are missing. We need to add in those correct symbols. Now, the very first part of our procedure tells us that there was a stationary front stretching from Long Island to Michigan, and that there are two little kind of black marks, one here and one right across here, to tell us that that's where the stationary front goes. In order to identify a stationary front, you would actually have to look at a series of weather maps to realize that it hasn't moved at all, which in this lab we didn't have the opportunity to do. So remember, a stationary front is going to be a mix of red and blue, and it's really the cold front and warm front symbols on opposite sides of the line. So I'm going to do that. I grab the blue marker here, and I'm going to start by making this little section blue and draw my little cold front symbol right on this side. Then I'm going to skip a ways, and I'm going to do that again in this spot. And then I'll skip a ways again, and I'll do that in this spot. So right now that looks like a cold front, but when I switch to my red marker now, I'm going to go ahead and fill in those missing sections, like right here. This is going to get my warm front symbol going that way, and this right here, like this. And then I'll do one last little section over here like this. So now I've drawn in the proper symbol for a stationary front, and this is really just to show us that the warm air is trying to move northward, the cold air is trying to move southward, and neither one is moving, so really that front is just staying in one place there. Now what we need to do is go ahead and color code the symbols in for the warm front, the occluded front, and the cold front. And it really doesn't matter which one we do next. So I'm going to go ahead and say, you know what, let me handle this front right here. Now, if I notice it's extending kind of generally off to the southwest, and I know a cold front usually does that, and then I look at the temperatures back here, 60 and 50 and 44 and 32, and then over here I see temperatures in the 70s with higher dew points, so I know that this definitely is a cold front. This is cold air pushing in. So go ahead and take your blue colored pencil, and we are going to draw the proper symbol, which would be the triangles, for our cold front on this particular line. And it doesn't really matter how many triangles you draw in there, as long as you have enough to make it noticeable. And just make sure they have nice little points to them so we know that those are definitely triangles that you're drawing out there. I'll put one more down here. I'll try to make that look a little bluer on the line if I can. All right, so there is my cold front, and you'll notice this is the same pattern all the time. It really does not change, so we're looking at the same pattern that we've seen all along. What I'm going to do next is look at this little section right here where it goes from the cold front to the stationary front. I notice that there's warm air pushing northward, and this is the warm front. So I'm going to go ahead and I am going to trace this out and put my warm front symbol on this. So that little section is my warm front, and that's where we have that warm maritime tropical air pushing northward into that particular section. And then the last part is when we have the cold front and the warm front merging together, we end up with our occluded front. I don't have a purple marker, so I'm switching to purple colored pencil here. And that symbol is going to be a mixture of purple triangles and purple semicircles, but they're all going to be located on the same side of that line. And this is to represent the occluded front, where that warm and cold front have combined together. So now I have my fronts drawn in. The next thing I want to do is, we know precipitation happens around the front, so I want to highlight those areas of precipitation. And the way we're going to handle this is we're going to look at the station model symbols for any place that was having precipitation, and we're going to take a green colored pencil and just lightly shade over that station so we could find the areas that are reporting precipitation. Now make sure it's precipitation and not fog or anything like that. We'll take care of that in a little bit. So the first one that jumped out to me is, I noticed right here in Oklahoma there's a thunderstorm. So since thunderstorm has rain, that's going to be precipitation. I'm just going to shade that over in green. I don't have to do anything too fancy there. I see some snow in Nebraska and over in Wyoming, so that's precipitation, so I'll shade that in. Some of this is probably due to the positioning of some of the mountains that are out there. And in Nebraska, it's because they're close to that low pressure center. And then I see two areas of rain, one in North Dakota, one in South Dakota, so I'm going to shade over that since that is precipitation. And then I see another area of rain kind of hidden under my fronts here in Iowa, so I'm going to shade over that in green. Got another one in Michigan. And I see one in Pennsylvania, kind of close to that stationary front. And one in upstate New York, also close to that stationary front. And I'll just do a quick scan, make sure I didn't miss anything. I don't think I did. And there we have it. So you'll notice with our precipitation, it's happening, we have one area right along the cold front, and it's a thunderstorm. That makes sense because we see short bursts of heavy precip along a thunderstorm, along a cold front. We see the rain ahead of the warm front. That makes sense because that's where we see it with the warm front, and it's just plain rain. Makes sense too because it's lighter precip. And then we do have some precipitation in the vicinity of that stationary front where those two air masses are colliding together, but not much movement is taking place. And then we see precip on the back side of the storm. Again, the snow that we're seeing in Wyoming probably has something to do with the topography that is out there. That might be more windward related that we're seeing there. The next thing we're going to do is we're going to shade in some areas that are known as obstructions to visibility. So we're going to use yellow for this. And this is going to be stuff like fog, that it is moisture, but it's not precipitation. And I really just see three areas of that. I see one in Minnesota where they're reporting some fog, so we have some moisture in the atmosphere near the occluded front. We see some more out ahead of the warm front in Wisconsin. And we see some more in Ontario, Canada here, out by that stationary front. And those three areas represent our obstructions to visibility, but it's not surprising to find them by the front where we have, that collision of the warm and cold air masses. The final thing that we're going to have to do here is the lab asks us to label some air masses over some specific states. The first state they ask us to take a look at is Arkansas. This is Arkansas sitting right in here. And what air mass is there? Well, there's a couple ways I could do this. First, I look at the temperature and the dew point. 75 and 74. So it's definitely warm compared to other places on the map. And the temperature and dew point are really close. That would be some really humid air. I also noticed that it's coming from the Gulf of Mexico. So a warm, humid air mass, well, that is maritime tropical. So in red there, I'm going to label that as an empty air mass, and I'll just kind of circle it so it stands out. I think I'm going to switch to the marker because it shows up a little better on the camera here. All right, so that's our MT, or our maritime tropical air mass. The next thing they asked me to do is check out Arizona. So I'm going out west here. Here's Arizona. And when I look at Arizona, I have two stations. One is at 70 and the dew point is 28. So that air is super dry. And then in northern Arizona, I see a 54 and a dew point of 20. So again, the air is super dry there. So I know that this is going to be continental since it is dry, and 70 and 54, that's much warmer than anything else on the map. So this is a continental tropical air mass. And that likely came probably from the deserts of Mexico, or perhaps even just formed right over Arizona. The next one for me to take a look at is in Ohio. So I go over to Ohio here, and I notice a 68 and a 66. So it's warm, it's moist. This is also going to be maritime tropical. And these two air masses are actually the same. They're both in the same air mass. So this maritime tropical air mass takes up this whole area that is sitting in here. The next one for me to go ahead and take a peek at is on the Vermont-New Hampshire border. So if I look up here and I look toward Vermont, New Hampshire, I have a station here that is in Massachusetts, and it's reading 58 for the temperature, and I got an arrow over my dew point, but it's something in the 50s here. So I know that is going to be moist air. And I could look up in Maine too, 43 and 39 for the dew point. So that's cooler and more moist. Probably came in off the North Atlantic Ocean. That is our maritime polar, or an NP air mass. So I'm going to go in and label that. Next up, we want to check out the Colorado-Nebraska border. That's right in here. Here's Colorado, here's Nebraska, sitting right in here. And if I look between Colorado and Nebraska, I notice that the temperatures are in the 40s. I've got one in Kansas in 50, in Nebraska in 32. So this is definitely cold air, so I'm going to make it a polar. And the temperature and dew point at these two stations, the one in Colorado, the one in Nebraska, and Kansas, are far apart. So I'm going to call this a continental polar air mass. And that's the cool, dry air that's coming in from Canada. The last one we've been asked to label is up in Montana. I look at the temperatures, they're definitely on the cool side. Temperature and dew point are reasonably far apart. We see the wind coming down from Canada, so that is also continental polar air. And these two air masses are likely the same. It's just showing how it's coming in from Canada. At this point, we have gone ahead and we have analyzed everything we need to on this map. We've drawn quite a bit on it. And this just shows you all the weather data that we can get just from station logs. That's really how this whole thing actually started. What you want to do now is you want to pause the video and go ahead and answer the questions that are in part C of the lab. And then when you're done, you can unpause the video and I'll go over the answers with you. But make sure you try them first. If you just listen to me explain the answers, the chances are you're not thinking through it enough to do well with it on a test. So take some time, answer the questions on your own, and when you're ready, come on back, watch the video, and we'll go through the rest of them. All right, let's start going over these questions. So question number one, it said, where did the air mass over Arkansas originate? Well, that's a maritime tropical air mass. It's warm, it's moist. And the only warm, moist area around this is the Gulf of Mexico. And if we look at the wind directions, that makes sense. It came right off that Gulf of Mexico. So for question one, we'd say that maritime tropic came from the Gulf of Mexico. Number two, where did the air mass in the northeast United States come from? Well, that is our maritime polar air mass, and maritime means it came off the ocean, or water, at least a lot of water, and the only ocean there is the Atlantic, and since it's cold, I would go ahead and say it came in off the North Atlantic Ocean. So that will be our answer for question number two. If we continue on to question number three, they want to know, well, what's the source region of the air mass over Montana? Go to Montana, that's a continental polar air mass. Where do those come from? Well, those came down from Canada. So Canada would be the answer for question number three. Number four says, based on the data on the map, are you more likely to find precipitation ahead of a warm front or behind a warm front? Well, if I look behind the warm front, I don't see any precipitation in here at all. But if I look ahead of it, I see rain and I see some fog, so that precipitation is happening ahead of the warm front. And that would be the correct answer for number four. Number five says, what two air masses are separated by our cold front? So I simply have to find my cold front and see what two air masses are on either side. Well, on one side I have continental polar, on the other side I have maritime tropic. So those are the two air masses that are separated by our cold front. Now number six asks us to make a little forecast. It says, based on the position and expected movement of a cold front, create a simple weather forecast for the next few hours in Missouri. Be sure to discuss the changes that can be expected in temperature and whether precipitation is likely or not. Well, if I go to Missouri, Here's Missouri. They're currently in a maritime tropical air mass. So at the moment, they are warm and they are moist. But I have this cold front that's approaching, and I know cold fronts are going to be moving in this southeasterly direction, which means it's going to cross right across Missouri. And then this continental polar air mass is going to come in behind it. But when that warm and cold air collide along that cold front, which we know is like a fist coming in, it's going to cause that air to rise rapidly, and we're going to get a short burst of heavy precipitation. So if I were making a forecast for Missouri, I would say, well, it'll start off warm and humid, followed a little while later by showers and maybe a thunderstorm, and then cooler and drier air that will move in a few hours. So since it's a cold front, this is all going to take place in a matter of just a few hours here. It'll go from being warm and moist, some showers and thunderstorms, to much cooler and drier air behind it. And that's sort of a standard cold front forecast. Question number 7 says, assuming the low pressure over South Dakota, that's this guy, follows the typical storm track, where will the center of this low pressure end up moving? Well, if we think about how the winds typically operate across the United States, the continental United States, we are in the southwest wind belt. So the winds always kind of generally move from the southwest to the northeast. So our storm track does the same thing. If this is our low pressure here, we would expect it to move toward the northeast. So for question number 7, you could say we would expect the storm track to move to the northeast. We have another lab coming up in the future where we look at that in a lot more detail. Now, number 8 says, notice the tight pattern of isobars in the Gulf of Mexico that is labeled as Karen. Based on the symbol, is this a tropical depression, a tropical storm, or a hurricane? So this symbol, when you see that symbol, that's either a hurricane or a tropical storm, and when it has the little opening at the center like this one does, that means it's a tropical storm. If it was a hurricane, it would be completely colored in. And for a tropical depression, they often just use an X on the map. So we're going to go ahead and say that this is a tropical storm. And then for number 9, is this an area of high or low pressure? Well, it's a storm, and we know all storms are low pressure. So you would say that it is low pressure, and then for evidence, there's a few answers you could give. One, you could say the isobar values are getting lower toward the center. Another option is that the winds are going counterclockwise. And another option would just be able to say, well, it's a storm, and we know that low pressure is the type of system that is going to have the warm, moist, rising air that produces clouds. The very last question, before you put a screenshot of this map in there, says, what is likely the source of energy for Karen? We are going to look at hurricanes in a future lab. And in this case, this tropical storm is sitting here over the Gulf of Mexico, and it turns out that is the source of energy. Hurricanes, tropical storms, any of those systems, they get their energy from the evaporation of that warm water into the air, and then when it condenses, when condensation occurs, it releases that energy into the atmosphere, and that is what causes the storm to grow in strength. So the Gulf of Mexico, the warm water there, that's the source of energy for Karen. Once you're done with this, make sure you go ahead and put a screenshot of this into your lab for the last question. That's question number 11. And then make sure that you flip through your lab and make sure you've completed parts B, part A, and the vocabulary, and that your name is on it. And once you have done that, you can go ahead and submit the lab.